In this video, we're going to be sketching a piecewise defined function. Now, a piecewise defined function is a function that is defined by two or more equations over a specified domain. Now, to sketch the graph of a piecewise defined function, you need to sketch the graph of each equation on the appropriate portion of that domain. It's important to note that if you're going to be using a graphing utility, that most graphing utilities display graphs in connected mode, which works well for graphs that don't have any breaks. But for graphs that do have breaks, such as the greatest integer function, or the one that we have here, it's better to use dot mode. So just be aware of that. So we're going to sketch by hand the graph of this piecewise function. So here we have the function 2x plus 3 when x is less than or equal to 1, and negative x plus 4 when x is greater than 1. And fortunately for us, if we look at our first equation here, it is a linear function. So here we can see that our m, or our slope of this function, is a 2, and our y-intercept is a 3. And if we look at our second function, it is also linear, and here we have a slope of negative 1 and a y-intercept of 4. Just clean that up. So what's important is this number here, this 1, right? Because it looks like one graph stops there and one graph starts there. So we see that on our graph, 1 is going to be a defining piece. So this spot right here is where something is going to happen, right? Right there, at the 1, okay? Now we know that our top equation, 2x plus 3, occurs when it's on the less than or equal to 1. So that means it's going to occur over here whenever it's on this left-hand side. That's where that's going to exist, right? And that our second equation, negative x plus 4, is when x is greater than 1. So it's going to be on this side of our line, right? So on this side of our line, but our blue one exists on the line as well, right? On the line as well and on its left-hand side, okay? So what we're going to do is now we're going to graph those, okay? So let's start off by graphing our top equation. So our y-intercept is 3, so 1, 2, 3, right? There's our y-intercept. And we have a slope of 2, so up 2 over 1, up 2 over 1, or down 2, left 1, down 2, left 1, and we can draw that line. Except remember that our blue equation doesn't exist over in that green area, so we've got to get rid of that spot there. Oops, let's put our green back so we know that that's not our zone, right? It's for the second one. So our equation, because it says that it is less than or equal to 1, then the spot on our line here is included, right? So then our line will exist back this direction. Okay, so let's graph our second equation. So here we have a y-intercept of 4, 1, 2, 3, 4, and down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. But here, it did not say, let's use pink, it just said greater than, that was it. So here we're going to have an open circle right here. But our line will exist going this direction. Let's fix that. So now if we get rid of our highlighted stuff, get rid of that, and we actually don't need our little y-intercept there because that doesn't exist. Oops, let's put that line back. There we go. And so we can see that that line at x equals 1 is kind of our dividing piece. If we get rid of that line, because that shouldn't be there, here we see our piecewise function sketched by hand.